Hi, everyone. Welcome to another episode of Spooky Software. Today is a very special episode. I have my friend, my colleague, the amazing Jasmeet here. She's hanging out. We're going to talk about domain name service, or DNS. And I think that a lot of our viewers are, probably web developers, experienced practitioners, and I think most people at this point sort of have an idea of what DNS does, but they don't necessarily know exactly how it works. And so Jasmeet is going to walk us through here, actually the more intricate details of how DNS works and some of those performance impacts. We're going to look into some CLI tools for debugging. And on top of that, we're also going to talk about a little bit about security as well. So I'm really excited about this, Jasmeet. I definitely feel like I'm one of those people that, doesn't quite understand the nitty gritty. I just know that this thing exists and, it does something with domain names. That's pretty much all I know.
Yeah, I'm excited to be here and to teach you a little bit more in detail about how DNS works. Cool. So I'm going to start here. I'm going to show you a diagram just to warn you it has a lot on it, but we will walk through it step by step. So this is a diagram about how when you type a website into your browser.
Yeah, perfect.
When you type a website into your browser or URL into your browser, this is I'm going to explain to you how you get all that nice content on your screen. So the first thing we'll go over just before we go through this diagram is content is hosted in physical servers, in physical locations. And basically your browser wants to know which of these physical locations to query to get this content. And so the way that we map these physical locations is using IP addresses, which is probably a term you know about. These are a series of numbers that are basically orderly ways to kind of keep track of where information is hosted. So I guess the question is, how do we get something like an IP address, which is a bunch of numbers, from English, which is like, facebook.com. So I will be going through this diagram and also using a tool, CLI tool called Dig. I think on Windows you can use NSLookup. And this CLI tool is basically going to help us figure out, what the browser is doing behind the scenes, kind of show you what the browser is doing behind the scenes as I go through the diagram for each step of it. So the first thing that we do when you type any domain name into your browser is the browser makes a request to the DNS resolver. And this is usually provided to you either through your operating system or through your ISP. So your DNS resolver is basically like the main dude who's going to be like doing all this work for your browser to figure out what does this name map to. And it's going to be asking all the questions for you, and then we'll give your browser the IP address in return. So Dig is kind of like mimicking what your DNS resolver is doing. So one thing that, the first thing that your DNS resolver will do is it's going to look at your domain name. So one thing that you might not know is that your domain name actually has a little dot at the end. So like facebook.com, and you'll have like a dot at the end of it. And this is representing the root, kind of like how in your file system you have an imaginary slash in the beginning of your directories to represent like the root.
Or maybe not so imaginary, right?
Or not so imaginary, yeah, that's true. But this dot is imaginary. So the first thing that your DNS resolver is going to do is it's going to query the root servers. And your DNS resolver knows about the root servers already. So it already has that information in it. So one thing that we can do here is we can query the root servers as well. So here what I did, So here what I did is I queried the dot, which is the root servers, and then I use NS to tell me what are the name servers, which I will get into later. And it basically gave me all these different root servers that I could query. So your resolver is going to ask the root server, hey, I need to know the IP address for facebook.com. And the root server is going to say, well, I don't really know where, I don't have any information about where Facebook is, but I do know where .com is because the root server has information about the top level domain servers. Top level domains are things like .org, .com, .edu. So the root server will respond back with information about, the top level domain servers for .com, and you can and then say to the DNS resolver, like, you can ask them for facebook.com. So if we look here, we can say com, and if you notice too, these comms have a little dot at the end, which represents the root server.
The sneaky dot.
The sneaky dot, yes, the imaginary dot. Cool. So now your DNS resolver has information about all these com servers, and it knows basically who to query to get Facebook, right? So it's then going to query the com server and say, hey, I want the IP address for facebook.com. So it's going to do something like that. So if you notice, you get back some names that are like a.ns.facebook.com, and you're like, what are these? Well, these are Facebook name servers. And so these are the servers that Facebook set up that has basically the mappings for the IP address to the web page. So in any of these name servers will have basically a table where it'll have your web pages, your English domain names mapped to the IP addresses. So once your resolver queries these name servers, it will basically be able to give you an IP address straight back. And then your resolver can pass that IP address to your browser. So that's kind of the overall sense of how it's working. And then basically once your browser has this IP address, it can then query the server directly for the content.
Right. And so you did that step by step with Dig there, but is there a way for Dig to kind of show us all the steps in one shoot, one output?
Yes. Excellent question. So if you want to mimic all the steps that your DNS resolver is going through, you can use this this flag called trace. And here, let me just make this bigger. Trace is showing you every single step that your DNS resolver is doing to resolve the IP address. So for example, the first thing it'll start with is the root. Mm-hmm. And it'll show you, oh, look, we got some information here. And this information, this 850 bytes, is probably or definitely is the information about what com servers that the resolver can ask. So then here we have all the com servers. And again, there's some information that comes back that probably gives it all the facebook.com servers. And here we can see, again, like what I showed you before when I was doing it step by step, that it, asking all these facebook.com servers. And interestingly, our last facebook.com is actually a CNAME, which is weird because, we didn't talk about what this is. And it gives you some address that's like starmini.c10r.facebook.com. So, this isn't an IP address. So this is kind of telling you, okay, we're not going to give you the IP address, but we're going to tell you where to find it. So it's kind of like maybe a link to another server that might have the information about the IP address. So let's try looking at this. We can see what happens. So again, we're asking for the root, we're asking for the Facebook name servers. And then here we can see that we're at, since there's like facebook.com and c10r.facebook.com, since there's a subdomain, each of these subdomains is handled by more name servers.
Right.
So in this way, DNS is kind of scalable. Like the more subdomains you have, you're not expecting all that information to be in one server. It can be distributed so that you can continue to add more. And here we have our IP address. So this is the answer. And this is now what your browser would use to look up the content. Okay, so now let me bring up this tab I went to earlier. So I was just messing around in my browser and I was wondering, what would happen if I looked at the network tabs for a website that I have never been to before. So I never went to vanityfair.com before, and I'll explain later why I'm emphasizing the fact that I've never been to this website, at least in like the recent past. And so I'm looking at these network requests, and I can actually Firefox DevTools lets me look at the timing of this request and breaks it down into the different steps that it's doing. And so you notice here that DNS resolution takes about 30 milliseconds. And you also notice that nothing else can actually start in this request before the DNS resolution finishes.
Mm-hmm.
And so this means that, you might not know this, but DNS resolution actually has, at least on load, a pretty big impact on your website performance. And it might not just be, the latency might not just be coming from like your big queries or things like that.
Yeah, in this particular case, we kind of noticed that 39 milliseconds versus 30, it's like it took just as long to look up the name as it did to download the content.
Yeah.
And that's
exactly.
like, in some sense, it's like 50% there,
And if we look at others, we can see that, for example, since we've never, seen this logo before, it also took about 17 milliseconds. And
yeah, half the time, literally.
yeah. And we can't actually start downloading any of this content until the DNS resolution is finished. So one thing that people have done to get around this problem, one solution that's been, come up with is, if you notice here, when I go to google.com, which is a website that I just visited pretty recently, if we look at the DNS resolution for any of the requests here, we see that it's 0 milliseconds. So how come our requests for DNS, for DNS resolution requests for google.com are so short, or actually like non-existent? Well, this is because we actually cache or DNS mappings that are either frequently requested or have been requested recently are actually cached in either your operating system or in your browser or in your DNS resolver. So this means that when you request the IP address, when your DNS resolver goes through all this work to get the IP address, once it gets it back, it kind of like stores it for a certain amount of time in the resolver itself or in the browser itself, so that the next time you request it, it doesn't have to make that like long journey again, and it can just hand it to you.
And so, Jasmeet, this is interesting. Maybe we can talk a little bit about the security implications of DNS.
Yeah, definitely. So as you notice here, I am going to google.com over HTTPS here. But this means that, everything that I do on google.com, if I'm entering any data, all my data is encrypted. But what this doesn't mean is that no one can find out that I'm going to google.com. So because of DNS resolution, all the information about what websites I'm going to and what IP addresses I'm visiting, those aren't encrypted. Those are happening kind of like publicly. So this is how, for example, if you search for something on Amazon and then you go on Facebook, you start getting ads for like whatever you search on Amazon. Oh, that's not a good example, because say you went to like, I don't know, I actually go to like the Fry shoe store website a lot. And then when I go on Facebook, I start seeing ads for like shoes from Fry. And this is because they know that I visited the Fry website, and this is like public data, because this, my like visiting history is not protected, since DNS is public.
Right.
So one thing that actually Cloudflare has come up with is DNS over HTTPS, and this means that they're kind of encrypting your, you know, your trail so that someone else can't come in and see that you've been visiting like whatever IP addresses you've been going to.
Cool.
So yeah, another example, another thing that to look out for with DNS is DNS spoofing. So I actually have a diagram of it here too. And oh, whatever, it's in the browser, that's fine. So this is basically when someone can pretty easily send you to a different website than what you meant to go to. So since there's multiple steps in getting that IP address, there's multiple different points at which someone can give you a fake IP address instead, and you'll be routed to that. So this is how someone can potentially collect your data, even though you think you're going to a secure website. So for example, if I wanted to go to facebook.com and, say that I got to like one of Facebook's name servers and someone hacked into it and they put their own version of facebook.com in there, and it just like Facebook, I got the IP address back, like my browser went to it and it looks totally like Facebook, and I put in my username and password.
Right.
That person who owns that website can now use my username and password to log into my Facebook, which is not good. So this is just something to be aware of security wise, as a possibility.
Okay, and so, Jasmine, I think I have one final question for you, and so this is something that, especially people who might be serving static content like HTML, CSS, JavaScript, even videos like on Netflix or whatever, they might use one of these content delivery networks, these CDNs, right? And so I know that I don't know the exact details, but I think that has something to do with DNS. Is that right?
Yes. So I can actually give you a great example. So a CDN is basically a way that people or companies like Netflix, for example, can host their content on different servers that are distributed throughout the world or throughout the country. And then using DNS, we can make sure that someone requesting information can get the information from a server that's closest to them. So that way they'll have, better performance. So I can kind of illustrate this with an example. So if I go to your website, spookysoftware.dev, I know, right? Here, we can kind of see that, okay, so, the dev servers come from Charleston roadregistry.com.
By the way, that is such a weird name server, Charleston Road. What is that? There's just like all these little tidbits in the internet like this. Like, what is this? I don't know.
And then we see that, Spooky Software is hosted on AWS, and AWS has these, 4 different name servers here that basically give me these 4 IP addresses here. So, interesting, but, kind of what we expected. So now, Eric, you're in California and I'm in Massachusetts. So
Right.
Why don't you try to do this same command that I did on spookysoftware.dev and send it to me? And you did. So now we're going to look at what your results were. And we see that, okay, so Charleston Road Registry is the same, which makes sense because, that's where dev is coming from. And then we see that we also have the same name servers for AWS, which also makes sense because that's where it's hosted. But then if we look here, we actually have different IP addresses handed back to us. So here we have like 13,226, but here we have 13,249.
Mm-hmm.
And so this could be happening exactly for the reasons that I was mentioning earlier. So these happen to be name servers these happen to be servers that are closer to Eric, and these servers are closer to me.
Mm-hmm.
So these AWS name servers are actually pretty smart. They're not just handing back the same IP addresses no matter who's requesting it. Mm-hmm. They're probably looking at, my IP address starts with a certain range of numbers because I'm on the East Coast. and Eric's IP address probably starts with a different range of numbers.
Mm-hmm.
And so based on, what our IP addresses is, it's looking up, okay, what are the ones that are closest to you and giving those ones back to us. And that is something that couldn't be done without DNS because, how there would be no way to map this.
Cool. Okay, I mean, I feel like we covered a lot. So we talked a little bit about what DNS does, what it does for you, how it impacts the performance of your website, either initial load latency, as well as how it can actually improve performance by giving out better answers to the question, right, of like what name maps to what IP. We talked a little bit about the security. We talked about how you can leak information about yourself by these DNS queries not being over encrypted lines. We talked a little bit about how you can an attacker might spoof a record and use that to basically phish things, for instance. Is there anything else you want to touch on, Jasmine, before we wrap up?
I think we've covered a good amount of stuff. So if you're interested, definitely there's plenty to delve into, I'm sure.
Yeah. I think also DNS is one of those things that on the surface seems very simple, but also can be quite tricky in practice because you have to kind of trust a lot of people. There's a saying in ops people or DevOps people might like the problem is always DNS because it's just like always manages to mess up somehow, I don't know. But anyway, at least our viewers now can use this dig tool to maybe quote unquote dig into things, right? Got him. Okay. All right. Well, thanks for watching, everybody.
Yes, thank you.
Bye.